China Space Station versus the ISS. Space stations are like a parallel world. Everything happening there was once considered impossible. Two space stations are competing for the privilege to send missions into near-Earth space, which will have an impact on its scientific and political density. With years of expertise, a wealth of knowledge, and the backing of the global scientific community, ISS is a seasoned veteran. China's newer, smaller Tiangong space station has emerged as a new rival though. Let's compare and contrast the two stations' differences and similarities. Hello and welcome to the latest Fly Me to the Moon video. If you like this video, don't forget to like and launch your rocket by clicking the subscribe button. Also click the bell icon. Let's start talking about this topic right away. China has been expressing a strong desire to join the International Space Station for almost 20 years. China's initiatives were always thwarted by the American government. In 2011, the United States vowed to stick to its guns by pressing Congress to pass a law that forbade NASA, or any other US-based organization for that matter, from cooperating with the Chinese space program due to concerns over national security. Anyone considering working with China on space issues had no choice but to do so from that point forward. China, too, had had enough. The Chinese must have reasoned that if they wouldn't let us in, we'd build our own space station, and that's exactly what they accomplished. Let's find more about Tiangong, also known as the Palace in the Sky, China's first permanent space station. Tiangong is a space station designed and launched solely by China in low Earth orbit at an altitude between 340 and 450 kilometers, or 210 and 280 miles above the Earth. It's a component of a larger and extremely ambitious manned space program. The space station will have three major modules placed in a T shape after the last module is installed in October 2022. It is tried and true modular architecture that has served the ISS well up to this point. Since 2021, the Tianyi core module has been continuously manned by 3 Chinese astronauts. The largest modular space station in low Earth orbit at the moment is the International Space Station, or ISS. 5 space agencies are involved in the international project: NASA from the United States, Roscosmos from Russia, JAXA from Japan, ESA from Europe, and CSA from Canada. Intergovernmental treaties and agreements define who owns and uses the space station. Astrobiology, astronomy, meteorology, physics, and other disciplines all perform research on the space station as microgravity and space environment laboratory. The ISS is ideal for testing the hardware and systems needed for potential long-duration journeys to the Moon and Mars in the future. The only station in space for 22 years was the International Space Station, except for a period from 1986 to 2001 when the Russian Mir station was in operation. The orbiting station once ruled space, but today it is challenged by multilateral joint effort with 5 collaborating space agencies: the United States, Russia, Japan, Canada, and the European Space Agency. The first module, the Tianyi, or Harmony of Heaven's core capsule, was launched on April 29, 2021, and 2 other modules are scheduled to launch the following year. How will the new station stack up against the ISS then? Let's begin with the fundamentals. How high is each space station in the sky? As opposed to Tiangong, which will orbit between 340 and 450 kilometers above the Earth, the ISS travels at an altitude of roughly 400 kilometers. In essence, the two stations do not significantly differ from this criterion. The Tiangong space station might be 1/5 the mass of the ISS when fully loaded, with a mass of about 100 metric tons or 220,500 pounds, but by coincidence, this is around the size of the decommissioned Russian space station Mir. Both the ISS and the Tiangong are powered by solar energy. Photovoltaics, a technology that converts sunlight directly into power, is used in the ISS's electrical system. To generate high power levels, many cells are arranged in arrays, but occasionally this process generates too much heat, which can harm spaceship equipment. The ISS uses radiators to transfer heat away from the spacecraft in order to combat this. These radiators are sheltered from sunlight and pointed towards the frigid expanse of deep space. On each module of Tiangong, there are 2 steerable solar power arrays. To turn sunlight into power, these use gallium arsenide photovoltaic cells. For the time when the orbiting station is not exposed to the sun, the station also just stores energy. These 2 approaches may appear to be extremely similar at first, yet they actually have significant distinctions. The primary difference is that the ISS utilizes wings, whereas Tiangong uses solar arrays. These solar array wings, sometimes referred to as SAWs, are the biggest ones ever deployed in orbit and are made up of 2 retractable solar cells, or blankets. Each wing weighs more than 2,400 pounds and, when fully extended, can measure 35 meters in length and 12 meters in width. The 4 sets of arrays can provide 84 to 120 kilowatts of electricity together, which is sufficient enough to power over 40 households. However, because the station does not always get direct sunlight, lithium-ion batteries are also used to power it during the night. These take up 35 minutes of an orbit's whole 90 minutes. When there is a sunlight, the batteries recharge. The ISS used nickel-hydrogen batteries up to 2017. From 2017 through to 2021, more potent lithium-ion batteries took their place. Similar to the ISS, the Chinese space station will be a third-generation modular space station. Space stations of the third generation are modular and are put together in orbit using parts that were launched independently. The ISS currently includes 16 modules, with 2 more sets to be added compared to the Chinese space station's planned 3 modules, the Tianyi Core module, the Wenshan Laboratory Cabin module, and the Mengshan Laboratory Cabin module. The ISS made up of 8 American modules: Beam, Leonardo, Harmony, Quest, Tranquility, Unity, Cupola, and Destiny, 5 Russian modules: Zarya, Pirs, Zvezda, Poisk, and Rassvet, 2 Japanese modules, the JEM-ELMPS and the JEM-PM, and 1 European module, the Columbus. The Tianyi Core module serves as the framework for the Tiangong space station. The primary component of the station, which also provides 3 crew members with living space and life support, controls the station's guidance, navigation, and orientation. There are 3 distinct parts to it: a residential area, a service area, and a docking center. On the other side, there are 2 parts to the ISS. There are 2 orbital segments: the Russian Orbital Segment, or ROS, which is controlled by Russia, and the United States Orbital Segment, or USOS, which is run by the United States and a few other countries. The ISS has airlocks and robotic arms that are extremely useful and effective. These features are absent from the Chinese space station. The space station was constructed with the aid of robotic arms. When astronauts conduct spacewalks outdoors, those arms can also help them move about. Science experiments are conducted by other arms, NASA released in a statement. The Chinese docking mechanism, based on the Russian Androgynous Peripheral Attach System, or APAS-89/APAS-95 system, is installed aboard the Tiangong. Both the Shenzhou spacecraft and the earlier Tiangong prototypes employed this. According to rumors, Tiangong's docking mechanism is an exact replica of the APAS system, making it compatible with the ISS's docking system. Tiangong's mission is quite similar to that of the ISS, which is to test spaceship technologies needed for extended journeys to the Moon and Mars. In the end, there are more similarities between the 2 space stations than differences. After all, they are both space stations. It'll be interesting to observe if the Chinese space station gradually expands to match the ISS in size and productivity. Its creators undoubtedly have the desire to achieve this. Whatever they accomplish, this challenging task remains to be unseen. And that's all there is to say about today's video. Don't forget to like and subscribe to our channel Fly Me to the Moon if you enjoyed this video. Click the bell icon to see more thrilling videos about NASA, SpaceX, and the Artemis program, the Blue Origin, and much more. Visit our channel to see more amusing videos, and we'll see you in the next video.